making sure I separated the last class from this. Okay. Okay, so what do? We're doing the square function in a rectangle, okay? What do you immediately do? Immediately do a center line here. Maybe do the center line here. Now we'll work from the right, and you go halfway from the right edge to the center, halfway from there to the center, halfway from the left edge to the center, halfway there to the center, halfway from top to bottom, which is this line, and halfway from there to the bottom, and halfway from there to the bottom, halfway there to the bottom, halfway from there to the bottom. And you label these lines, you're gonna get x equals 8 in the middle. You're gonna get x equals 4 here. You're gonna get x equals 12 here. You're gonna have x equals 6 here. You're gonna have x equals 10 here. And of course, we did those in class last time, but that's fine. Intentionally gave you something that was fairly familiar. Not totally familiar because I threw 48 at you. Okay, and in class it was 32. All right, so we're going to have to label these ones. Well, what's halfway between 48 and 0? Well, should be able to do that arithmetic in your head. If you need to use a calculator, be okay. 24, halfway between 24 and 0 is 12. And yeah, I'm blocking the board. Halfway between 12 and 0 is 6. That's of course y equals. And then down here we have y equals 3. And then all the way down here, it looks like we've got y equals 3/2 or 1.5. Use the mixed number. Okay. So we make a table. Well, first we make our graph. Let's start at the upper left. This is where we start. We make a point here, right? So that we can follow the algorithm, which is go right 1 down 2. Get this one. Right 1 down 2. We get this one. Right 1 down 2, and we get our red dots. Is the point on the graph, so next to that. And then go right 1 up 2, right 1, right 1 up 2, right 1 up 2. And we sketch. Okay. So it's a good idea to do things in order. Sketch the function in a rectangle. We just did it. No, I didn't do it in order. I labeled the construction lines before I sketched the function. Okay. Might not be a bad idea to do it in order, even though I didn't write it that way. Okay. Now, some of you then skipped, many of you skipped down to making a table for this formula and did a good job of it. Okay. If you don't have a table for the construction points, though, it's going to be hard to figure out how to modify your function. Okay. So you heard me. I told a lot of you, think of these construction points. Well, that's pretty easy, isn't it? We just look at the construction. What's x and what's y for this point? X is 0, y is 48. No, I don't have room here. So let me. Constructed, right? 3, 10, 24. For first place, our points are not -2 through 2, they're 0 through 16. So I was doing something else last class and just straight my brain started. Okay, so we got 0, 4, well, we got 0, 4, 6, 10, 12, and 16. And 8, of course. Okay, and now, so we got for x equals 4, we have y equals 12. Yeah. And for x equals 6, that would be here, y equals 3. We get 0, and we get 3, 12, 38. So there are enough. Okay. Doesn't take long to do that. Do it in order. Maybe don't do it quite as quickly as I can. You can do that pretty quickly, okay? Because this construction is automatic. I didn't see any bad constructions out there. I didn't look that closely, but everything I looked at looked good. Okay, very good. And almost everybody has the right points. We can miss it. Points, but the whole picture looks good. Okay, so pretty pleased with all that. Now we got to get into doing a little arithmetic and algebra. So first we're going to test the formula y equals x minus 8 squared. If x is 0, 0 minus 8 is -8. -8 squared is 64. Just do calculation off to the side. If you're doing this with a calculator, square -8, you better put that -8 in parentheses before you square it. Otherwise, it's going to tell you -64 because it does the exponent and then it does the number and then it puts the negatives on it. Order of operations. You should be aware of that. And you should be aware of if you square a number and get a negative, something screwed up. Okay. Yeah, you probably understand what it was. You guys all actually. Okay. But don't let that slip by. Okay. So we got 64 there. Now, if x is 4, we just do the same thing. 4 minus 8 is -4. You square -4 and you get 16. And then 6 minus 8 is -2. Square -2, you get 5. Here you get 2, and then you get 4, 16, 64, and there it is. That's this. Okay? And it's all very straightforward. Now, one thing, you see a bunch of questions to break this problem down. Okay? You know, ultimately, I could have just said, okay, if you do a square graph here, you're going to know soon that that's going to be some multiple of x minus 8 squared. If I just ask you, okay, what multiple of x minus 8 squared is that? Without giving you these intermediate steps, it's going to be a little tougher to make that jump, right? So I'm giving you a bunch of intermediate steps here. We'll see how to make this jump, and it's not difficult. Okay. Still, we got these two tables. And what we've said is, well, okay, here's our graph. Here's the x minus 8 squared function. They don't give you the same numbers. These numbers are bigger than these. Well, how much bigger are these numbers than these? Way we could do this is do it like this. Be a useful thing. Your graph gives you 48. We could put the x values here, 0, 4, 6, 8, and so forth. Graph gives you 48. X minus 8 squared gives you 64. Ratio, what's 64 divided by 48? You can reduce that fraction, 64 divided by 48. Well, you could divide both of these by 2. That would give you 32 over 24, right? And you could divide both of these by 2, and give you 16 over 12. And that gives you 8 over 6, which is 4 over 3. The ratio is 4/3. Okay. Now, if x is 4, graph gave you 12. X minus 8 squared gave you 16. Ratio is 16 over 12, which is also 4/3. Okay. One more. We've got 3 here and 4 here. What's the ratio of this over this? That's 4 over 3, which is already 4/3, right? We see a pattern here. It's always 4/3. Okay. So the numbers in this table are always 4/3 as big as the number in this table, right? So if we want to get the number on this table, what we do to this number. If this is 4/3 of this, then this is what fraction of this? 3/4. Okay. So say x minus 8 squared is 4/3 of graph numbers. Graph numbers. This is off the screen a little bit again. 64, 48. Well, put 64 here, 48 here, we'll do the ratio. 16 over 12 is again 4/3. 4 over 3, of course, is 4/3. See, the 64 over 48 is 4/3. We reduce the fraction 64 over 48. Now we can divide both sides, numerator, denominator by 8, even by 16, and reduce it a little quicker. Hopefully we know how to reduce fractions. Okay. Now, from this, we figure the pattern is this is always going to be 4/3 of this. So the x minus 8 squared is always going to be 4/3 of the number on your graph with the same value. So the numbers in your graph reinforce x minus 8 squared. If these are 4/3 of these, then these are 3/4 of these. Okay, makes sense? Now, I'm not going to have you do a whole lot of that. You're going to do some other stuff. But making a point here, just to reinforce the point we made in class last time. Okay, make sure you understand what we did in class. Where the ratios were easier, it was half and double. Okay, I threw a little bit of a curveball at you. But just to see what you do with it. Some of you got it, which is pretty good. Now I want to go back to this graph here and get something else. First of all, we could estimate the value of y. Sorry, the solution to the equation. And there's 12, there's 24. Do 16. 16 is about a third of the way between 12 and 24. I'm going to say here's a line, y equals 16. Here are the two vertical lines. Tell me the value of x such that y equals 16. Here it looks like x equals what? Here's 0, here's 4. Closer to 4 than 0, you might say 3. I'd say it's a little more than 3. I'm going to say 3.2. Now, this is an estimated solution of f of x equals 16. Okay. I'm saying x is about 3.2. And here I'm saying x is about 12.8. I don't get symmetry in my graph. I don't know how that happened, but I accidentally did it pretty symmetric. Not great. Okay, now we understand how I did this. You've done these estimates. Everybody familiar with what we do there? They estimate the solution of an equation, f of x equals 16. Right? Now we know that f of x is 3/4 of x minus 8 squared, right? So here we've figured out that f of x is 3/4 of x minus 8 squared. So this equation f of x equals 16 becomes the equation 3/4 of x minus 8 squared equals 16. Do we understand that? If this function has a formula, then we can say y equals f of x. The formula of y equals f of x equals 3/4 of x minus 8 squared. Then the equation f of x is 16. You just replace f of x by its formula, and here's your equation, right? Okay. Now the question is, how do we solve this equation? Now, if you are pretty familiar with solving equations, you're going to have to hustle a little bit. Okay. So if you aren't familiar with how you solve equations, you need to let me know. There's some open math exercises that will run you through. If you don't know how to solve equations, you really ought to be in the NDE 61 as well as this. Okay. But I can give you the same materials. You'll have to work on them yourself. I give you the materials and look at how you do. Okay. Make sure that you get it. Now, I think for most of you, maybe for all of you, this will come back to you pretty quickly. Okay. Before I solve this equation, I want to solve one that doesn't have the complication of a fraction. So let me say I have the equation 2 times x minus 8 squared equals 16. Okay. Now, if it was 2 times x minus 8 squared, 2 is more than twice as big as 3/4, right? That would make the graph a lot higher because you'd have bigger numbers, right? Bigger y numbers. If you have the 2 here, you have 3/4. So you can imagine either relate with this graph, different numbers, or make the graph a little steeper. But we can visualize this as an equation. Where you can say this is our line y was 16. And we know we're going to get 2 x values. That's like x approximately what x approximately question mark. Probably can't read it. That's a schematic of what this equation means. That makes sense? Because we've already done the whole idea of estimating x for a given y and estimating y for a given x. Okay, did that almost the first day. I think we did it the first day. Okay, now we got to do a little bit about. Okay, so write down this equation and write down the first step you would take to solve that equation for x. I just want to see how many of you can do it. I anticipate some will, some won't. And you're welcome to surprise me and everybody get it, but you know, it's something you might be a little rusty on. Now, just talk about the first step. But I think a lot of people, I think probably the majority of the class got it. Step looks like this. You divide this side by 2, you divide this side by 2. Okay? And then this 2 divides this 2, leaves you x minus 8 squared. Over this side, you get 8. Okay? And many of you had it, and some people didn't quite get there. Okay. Let's just say we wanted to isolate the x minus 8. See, we want to get x minus 8 squared equals something, right? What would we do to both sides of this? You can write this one down and show me what you would do. Just want to see how you're dealing with it, so I know how much explanation you're going to need. Okay. Now, there are 2 correct things I see people doing, okay? One is imitate what we did here. We have a 2 up front here. Well, we divide by 2. It divides out, right? So we can do we can divide this side by 3/4. We can divide this side by 3/4. Okay. 3/4 divides 3/4, leaving us x minus 8 squared. And what's 16 divided by 3/4? Well, you're dividing 16 by 3/4 means you're multiplying 16 by 4/3. So that's a rule for dividing by a fraction. Now, if you don't understand multiplication, division, addition, subtraction, fractions, you want to review that soon because it's going to be really important. Okay? And it's fifth grade stuff. No insult that you don't remember it if you did it in fifth grade, because that's been a while. And you haven't had to do much because the curriculum doesn't do much with fractions. Okay? Not really your fault if you don't remember how to do those things. My point is, you learned it when you were in fifth grade, you can learn it now. Okay? So do that. Okay, so we got 16 times 4/3. So you get x minus 8 squared. 16 times 4/3 is 64/3. Okay? And then you can solve that. Now we'll talk about the stuff you do to solve this. But first, the quicker one we get the same thing would be start with true force of x minus 8 squared equals 16, and you multiply both sides by 4/3. The whole issue of dividing by a fraction. Okay, you just multiply by the reciprocal, whatever this number is. Okay, and here essentially we multiply by the reciprocal of 2, which would be 1/2. Divided by 2 is the same as multiplying by 1/2, right? Okay, so we do this, and now we get x minus 8 squared equals 64 over 3. With fewer steps, less calculation and less headache. Okay. So of those, we did the right thing here. Most people did the right thing, did the reciprocal. But a significant minority of people who did the right thing divided by 3/4. Problem with that is not everybody knew how to divide by 3/4. Okay. But you should know that. You should also know that multiplying by the reciprocal will wipe out that 3/4. Okay, so now we've got, over here, we've got x minus 8 squared equals 8. So x minus 8 equals plus or minus the square root of 8. That's how you solve x. That's how you solve this squared equals that. If this squared equals that, then this is plus or minus the square root of that. Something you should have seen a good bit of, but it might have been a bunch. So you want to kind of just know that that's the case. If it's over here, or either one of these leads you to x minus 8 squared equals 64 over 3. You get x minus 8 equals plus or minus the square root of 64 over 3. And that's something you can punch into your calculator. But sometimes you need to simplify it. You know, like the square root of 8 is 2 times the square root of 2 and stuff like that. But often, just being able to plug it into your calculator for right now, that's fine. Okay. Later on, we'll want to get a little fancier with our expressions and our simplifications. But I don't want to lay too much algebra on you all at once. Well, now, you know, if you think about it, that you have a method that whatever dimensions I put on this rectangle, you can solve the equation y equals whatever. Okay? You got it all. The one thing you have to know is that wherever the red dot is, you're going to have x minus that number squared. Okay. So the x minus 8 squared is your red dot number. Of course, this only works with the squaring function, okay? Reciprocal function is actually somewhat easier. You just know how to do reciprocals, okay? It's actually pretty easy to solve those equations. We won't do it today. Exponential equations is going to take us until sometime in late March, because we just don't really develop the machinery for exponential equations until we get there. But it turns out the machinery is pretty easy. Probably easier than a lot of this. Okay, that's nothing to dread. People usually do pretty well at that point. Okay, now there's some stuff here between here and this point gets really pretty hard. Okay, so you've got to develop the algebra so much slowly. First thing I want to do with algebra is know how to solve one of these equations. Okay, I'm going to give you another one just so you can solve. Solve that equation. Now, we actually haven't finished the solution. There's one more step. At least do what I've done. And if you know what to do in the final step to get X, go ahead and do it. And I'll wrap up with that. Okay. So this equation, we divide both sides by 16. Giving us X minus 3 squared equals 5. You divide 16 into 80. If you want to keep it 80 over 16, you can, although I prefer you reduce it to lowest terms. Okay. By the time you get it down to lowest terms, you're going to get 5. Still, if you want to say square root of 80 over 16, something to put in your calculator, get the right number. I'll live with it for right now. I just want to see the algebra steps. But I'd like, still do as much of the arithmetic as you can. Well, I don't have room down there, so I've got X minus 3 squared equals 5. So that X minus 3 is plus or minus the square root of 5, right? And that's just automatically. If something squared equals 5, then that something would be the square root of 5 or the negative of the square root of 5. And that's something you should totally understand. And I'm not going to go through a detailed explanation of it because you just got to know what squares and square roots mean. Another thing you might need to review. But you'll probably get used to it. Okay, now how do we solve this? What do we do next? We still want to solve for X. If I add 3 over here, I get X and plus 0, so I just get X. And over here, I've got 3, and I got plus or minus the square root of 5. And we usually write the number here in the square root. The number first and the square root second. 3 plus or minus the square root of 5. Now that's something you put in your calculator, okay? Square root of 5 is about 2.23. Something like that, okay? And you can add that to 3, get 5.23. It could subtract it from 3 and get 0.87. Okay. And the numbers you get, if you had a graph of the function and you did all the lines and stuff like that, would agree. Okay. Now let's just see what we get here. Okay. For this function. Okay. If we complete this, we ought to get numbers close to 3.2 and 12.8. Those are my estimates. If I estimated halfway well, it should work. Okay, well, x equals then 8 plus or minus the square root of 64/3. Well, I'll just do my mental arithmetic, and then you can plug this in your calculator, okay? While I'm fumbling over the mental arithmetic, find the square root of 64/3 is a decimal, and add it to 8. Calculator, what I'm doing. And don't tell me what you get, because you get the laugh at my approximation. So let's see, that's going to 1.732. Come on, working memory, come back. It'll be about 1.7. And then, I'm sorry, 3.4. Or 12.4. Or 12.6. And those are my estimates when I do calculations. So who got up the calculator? Let's see how I did. Hang on a minute. Okay, now I committed myself. I felt kind of okay about these little calculations that I did, but they were kind of complicated, a lot of working memory involved. I didn't trust it as much as I trusted my graph. I thought my graph was pretty good. Now, they weren't that far apart, 12.8 versus 12.6, 3.4 versus 3.2. But I trusted my graph a little bit more, but it turns out that I nailed them all. A little bit surprising. I won't always do that. Okay. Next thing you see me do is add 2 and 2 and get 12 or something. 22. Okay. Bell calculation or graph, correct solution comes from solving the equation. Okay. The graph gives you a good idea. If you get 3.4 and 12.6 here, and your graph says 42.8, 396.4, either your graph is really screwed up or your calculation is really screwed up. Okay. If they are very divergent. If they're close, then I'm pretty confident that they're close. They're close to the right solution. Does that make sense? So getting these, if I put this into the calculator, this is what you get from the calculator if you round off to the nearest tenth, I think. Okay. Then the graph would give you good confirmation of your calculation. The graph is never going to be totally accurate. If you do a pretty good graph, you get pretty close. Okay. And I don't expect you to be an expert at making an estimate off the graph, but I expect you to be able to do reasonable estimates. And from the quality of the subdivisions you're doing, the quality of the graphs, I'm saying you do, especially if you make the graphs a little bit in many cases. Just have I think you get some pretty good estimates, okay? And the graph gives you a picture of what the equation. Okay. Now, there's other stuff I wanted to do, but, you know, we have to talk a little bit more about some of the different elements that I wanted. There is an assignment to open that. And I'll ask you a couple more questions, a couple more problems. You haven't done the problem that I put in the assignment form yet. Okay. Should be in your notebook. If you didn't look at the assignments page, we didn't have it. I'll put it there fairly early in the afternoon of Tuesday. And look for the assignment, which ought to be there this afternoon. It'll be due Tuesday, okay? And let me close this out.